In this lesson, we're going to talk about parameter scope. And when I talk about scope, I'm talking about the visibility of an object in a program. And I'm going to start out, before we get to methods and parameter scope, we're going to talk about general scope of variables. When I write a line of code like int a equals 12, and then I write system out println a, the scope of the variable a is the method public static void main. In other words, anywhere inside this method definition, our main program, I have access to the value stored in A. So we call this local or method scope. I can also put a variable definition in what's called the global scope or class scope. And now A can be visible anywhere in the program, even outside of main. We're going to talk more about that when we get to object-oriented programming. We also have something called block level scope. For example, if I write for int I equal 1, I less than equal to 10, plus plus I, just a standard little for loop, by declaring I inside the for loop heading or definition, I'm saying that I is only visible inside this block from here to here, from the opening curly brace to the closed curly brace. If I try to access I outside that block, I get an error saying that I is out of scope, or some similar error. Methods work the very same way. If I write, whoops, I got a little ahead of myself there. When I write this method definition, square, then I am saying that the value of number is only visible inside the method. And even more than that is, once the method has stopped, then I can't access number at all. To demonstrate how that works, let's use that method in a program. Let me get rid of this last line before I discuss what's going on here. So you see what I've done. I've declared a variable num and set its value to 2. Then I call the square function to square it, and then I display the value of num again. Let's see what happens when we do that. Oops. Oh. Helps when you spell things correctly. Let's try it again. All right, now we can run that program. So, remember, num was 2 when we started. When we show the square, we have 4. But then when we go back and look at num again, the value of num is 2. The reason for that is that we say that Java passes parameters by value. Whoops. What that means is that it passes a copy of the argument to the method. And then when the program goes back to the main program, that copy is gone. So for example, just to go through this square method, when we pass num, num is passed by value and mapped into the parameter number. They have the same value at this point. The value of number is accessed in order to square it, so we have 2 times 2 to get 4. 4 is returned, but that's only shown right here, and you could almost consider it like a literal value, the literal number 4. The return value of square num is a literal 4. Num's ultimate value is not changed, and that's because Java passes parameters by value. Other languages allow you to pass by reference. C++ is a good example of that, so is C#. But Java only allows pass by value. So what that means is that you can never pass an argument to a method and have that method permanently change that particular argument's value permanently. There are some tricks around that by using other types of objects like arrays and array lists. But in general, you can't change the value of an argument permanently through a method call. And that is because, I'm going to put a little comment out here so you can see it. Java is a pass by value only language. And so hopefully that will help you understand how methods work, what happens to the parameters values inside of methods, and why they don't actually change after you're finished with a method call.